Right, welcome. We're going to have a look at some physics. We're going to have a look at specific heat capacity. What is specific heat capacity? Well, I want to heat two substances up, and one of them requires a lot more energy to try and heat it up than the other one. And that is this property of the material, its specific heat capacity. Let's have a little look. So what we've got is basically a block. And this block is going to be made of some sort of material. And what I'm going to do is I'm going to heat this. Now I can measure the amount of heat I put in quite accurately. And what we're going to look at is temperature change. There is a formula, E equals mc delta T, sometimes delta theta. Delta means the change of. So energy, which could be volts times current times time, measured in seconds, equals the mass times something called this specific heat capacity times the temperature change. So different materials, zoom the wrong way, different materials have different amounts of energy required because they have a different specific heat capacity. Different materials require more or less energy applied to them to raise their temperature. So our specific heat capacity is the amount of energy required to heat up 1 kilogram of a substance by 1 degree Celsius. Now, to make life easier, I've got some items to heat up, and I've got over here, probably easier to move here, I've got some different items. Let's have a block of brass, a block of aluminium. I've got a block of iron. I've got a block of copper. So I've got several different blocks. I've got two duplicates of some of these. And what we're going to have a look at is trying to heat up these and get some sort of comparison between them. Now, these blocks are different sizes, but they should all be the same mass. So let's have a quick look on here. And if I take the brass, I had a feeling I was going to have that problem. I just grabbed balance quickly and it's outside its range. Let's go for a different one. Block of brass here weighs 1 kilogram. Much larger than that is this block of aluminium, which weighs 1 kilogram. So although these are very different sizes, they actually have the same mass. A block of iron. How boring. That one is 999. have another block. Let's see if this one's any better. That's worse. 999. And a block of brass, again 1 kilogram. So I've got 3 all weighing 1 kilogram, copper, brass, aluminium, and unfortunately my iron seemingly to weigh 0.999 kilograms. 999 grams. Okay. We'll put the mass aside for the balance. So we've got these masses, and what we're going to do is we're going to try and heat them up. How to go about this? Well, I've got a power supply, and what I'm going to do is just plug the power supply in. This is going to give out a suitable voltage, and I'm going to set this to about 12 volts. There for the time being. I've got a block to heat up, so let's just take one of these to start with. And I think we'll start with aluminium. I'm going to lay it on this piece of polystyrene. I normally have a smaller piece. I've just lost it temporarily. And to stop the heat escaping too much, we're going to use phosphorus to insulate it. I'm going to use a small immersion heater. Now there's a problem with this one. It's too long. And this piece will heat up, and it won't heat up my block. So we're going to probably lose a little bit of heat. It's much better than the first one that I bought. Someone had a sense of humour, and they supplied one that length to go in. And very good it is too, apart from most of its length is wasted. So I'm not going to use that one. So we're going to use this one. It's not quite the right length, but it is about the same length in each one. I think that's why I have to use that one. Take the brass. It's going to go in there. Make quite a good fit and copper. They are quite a tight fit, which is good because we want the maximum amount of contact we can. Got my aluminium block, and we want to know its temperature. I've got 2 options for thermometers. I've got one that ranges from 0 to 100 Celsius, or one that can go up to 50 Celsius. I'm not going to heat this up too much, so I'm going to use this one, the 50. And we're going to try and make sure that when we heat up the block, I'm not going to go too far. The temperature of this block at the moment is about 26 centigrade. I believe the block and the thermometer have been sat next to one another for quite a while, so they should be the same temperature. And I'm going to raise the temperature of this up to somewhere in the region of about 40 centigrade. I'm not going to make it that hot. We're going to look at how we're going to try and wire this up. So I'm just going to take the thermometer out so I don't break it, because I've not crossed in a minute. I'm going to take this out as well, and let's look at how we're going to wire up. I want to come out, we're going to use DC, and I'm going to go to my supply, to this heater. I'm going to come out of the heater, and I'm going to go to an ammeter. and a voltmeter. So this is my ammeter. Just checking which one it is. So it's going to go to my ammeter. All right, broke that. I'm going to go to my ammeter, and then I'm going to go from my ammeter. I seem to cut as large wire as I can, longest ones I could. From the ammeter back to the supply. Then I've got my blue wire, so I can pull them apart. I'm going to go and connect my blue wires to a voltmeter. So I've got the voltage across this supply. So we've got power. Normally putting out 12 volts, I'll adjust it. We've got then 2 meters. The blue one of the blue plugs is going to be my voltmeter. And we'll have a look at that. And we've got the ammeter set there. I don't know whether I've got my ranges yet. And I'm just going to put it on very quickly, just for a moment, just to see what is my voltage and everything else. So switch on. I've got 11.1 volts. Just going to raise this up a little bit so I can get to 12 volts. I've got 0.7 amps, and we're ready to go. Right. So yeah, hot. Nah, fine. Right. We'll leave that to cool down. Anyway, my 2 meters are ready. And typically my battery's low on that one. I may have to replace that. Let's take my block. I'm going to wrap it with my little bit of insulation. Just try and keep it relatively insulated. Can't do much about the top because we've got to put in here a thermometer, and we need to put in the immersion heater. So I've got the temperature at the start, so I'm going to record some of these bits and pieces. So let's start with my pencil. So we've got aluminium, and I need to record the time. And we're going to measure that in seconds. We're going to record the voltage. We're going to record the current, the temperature at the start, the temperature at the end, and we've got a stopwatch here. We're ready to start. So we've got 1 kilogram here, and the temperature at the start 26 degrees Celsius. My insulation tape stickiness is going. Will do. Right, so hopefully you can see all of those bits and pieces. And we're ready to start. So here we go. Can you press the start button for me? 3, 2, 1, go. We've got then 12 volts. My current is 0.7 amps. And we'll see what happens. Now it's going to take a little bit of time to get going. Why? Because the heat from this heater, and I can feel the heat radiating out on my finger there, so I know I'm wasting some heat. It's going to take time to dissipate through this aluminium block. It's only going to move by conduction that we looked at in the last session. So only by conduction is the heat going to move out of here, and it's got to move this distance, which is about 1 centimetre to this thermometer. I'm looking at my ammeter, it's changing from about 0.7 to 0.8, so it's probably actually going to be about 0.75, but I'm guessing there. I'll just record the fact it's changing. At, I shouldn't breathe. 1 minute 30, we're up to now 28 degrees centigrade. And it's climbing slowly. I'm probably only going to take this. I'm going to aim for about 36 centigrade. I'm just going to raise it by 10 degrees. And the reason I'm going to do this is I don't want this to be too far off of room temperature, because heat is going to be lost from this block by radiation and other means. So we're up at 30 degrees now, the time being 2 minutes 25. It's steadily rising. We've got to 31 degrees. So we are rising about 1 degree about every 20 seconds. I'll fix this one in the next experiment. 32 degrees centigrade. You want it around a bit more to help? I'm trying to do it so you and I can both see it. Oh yes, you can see it nicely. It's going up. So just keeping an eye on the thermometer as it's rising up there. You can see 34, so 2 degrees to go. Coming up on 35, so I'm going to get ready to stop this in a moment. Too much. And there we are, 36, and I'm going to stop at 4 minutes 27 seconds. Now, there's a problem, and if you're looking at the thermometer, you'll probably notice this. So I've switched it off, but the temperature is still rising. Now, why is this? Very simply, my immersion heater didn't start working immediately, and now at the end it's still carrying on. Basically, heat was put into the system, and this is now still quite hot, this immersion heater. It's still radiating its heat out to this block, so the block is still heating up, even though the electricity is no longer running. So I'm going to leave this and record the maximum temperature that we get. So at the moment, I've got to 38.5, and we'll see that our temperature will gradually decrease and going up. It's going up quite quick, and then it will go up less quick. Still rising. Tape. I don't want very much. I don't want it to stick too well. Temperature now 39 centigrade. I'm just waiting to see how well up it goes. Paul's trying to focus on the thermometer for you. There we are, we're up to nearly 39.5. Some people argue that you're better off with a digital thermometer. My experience with those is that they aren't any more accurate than an analog thermometer, and sometimes they're much worse. I have two thermometers in my pool. I have a digital and an analog. The digital tells me all sorts of numbers, lots of decimal places. And if I try different ones, they'll give me different temperatures. The analog always gives me the same one. I think we're going to call that 39.5. It's probably not going to go up anymore, so I'm going to think here 39.5. Okay. So what I'm going to do is I'm going to take my thermometer out, take the immersion heater out and leave that cool, and we're done with the experiment. So now my block. The only difference between this one and the other one now is this one is just slightly warm to the touch. The other advantage of trying to do this not too hot is it makes it much safer to try and work with. So there's that block. Now we're going to try a different block to see how well this works. I am tempted to go with the iron because the iron's going to have probably the greatest difference, because when we did our last experiment with this, we saw that it was the iron that had the lowest conductivity. So this one is 995. So I'm tempted to try that one. The reason I'm going to use that one is you probably noticed I put the thing in fits, whereas I've got a different block. And unfortunately, this one, even though they came from the same manufacturer, it doesn't fit. So it's not very helpful. The big one, on the other hand, will fit in there. Just useless. Right, so I've got for my iron a mass of 995 grams. And let's see what we've got with this one. Let's get set up exactly the same. So with my new super gaffer tape to arrive, I'm going to wrap this one up. It's going to be a little bit more snug than the previous one. I'll put the thermometer in and we'll get a recording of what the temperature of this block is ready so that we can start the experiment. I'm giving a little bit of time because I want this to cool down and I want to be happy that isn't hot to hold. We haven't heated it up very much and that really isn't very warm. So it's not much different than it was before. So let's get a reading from this block. And at the moment it's just falling. I would imagine it's going to be about 26. And we'll just leave that for a moment to get going. We're hoping then the voltage is going to be the same. I'm hoping that the current is going to be the same. And I want the starting temperature to be about the same as well. Because this is what we want to do when we do these things, to get these things to repeat accurately. What I would do if I'm doing this as a real experiment rather than a demonstration is that I would use this block not once, but I'd probably do this experiment at least 10 times. We're falling still, it's 26.5 here, down to 26, where I believe it is going to stop. So I think we're ready to start. Temperature around here, using the other thermometer, is about 26 centigrade. So I think we're ready to start. Experiment doesn't take too long. So I'm going to put in the immersion heater and we're ready to start. So 3, 2, 1, go. We've got a temperature start of 26 degrees Celsius. And I'm going to run this to the same temperature. I'm going to aim for 36. But in fact, it will rise up a little bit more. And we know that iron has not such a good conductivity as the aluminium. The thermometer, however, is actually closer to the immersion heater. It's about half a centimetre away this time. So we're just coming up to a minute, and my temperature here is 27.5. I'm looking at the ammeter running, it's saying 0.8 all the time for this one. So I'm going to make this one 0.8. Store 12 volts, 0.8 amps. Start at 26. And now, after nearly 2 minutes, sticking my head away, we're at 31.5. I'm working out it's actually a lot easier for me to have a look at the screen like you. So coming up on 34 degrees centigrade. I believe it seems to be running faster than the other one. 35.5 and coming up on 36 and ready, steady, stop. So this took us 2 minutes 52 seconds. Which is considerably short time. First one was 4 minutes, 27 seconds, 2 minutes, 52 seconds. So a much shorter time to heat up. The temperature is still rising. And we're now on 39. This one I think is going to shoot over 40. And then we're at 40. It should start to slow down. And we need to leave this to reach its maximum temperature so we can record the maximum amount of heat that was put into the device. My system doesn't work very well. Still. We're on 41.5, approaching 42. It might just about make 42, I think. It's really slowing down now. It's just like 42. Just now leaving it just a fraction longer. Will it make 42.5? I think we're going to call that 42.5. So 42.5 degrees Celsius. I'm going to take out the immersion heater. I'm going to take out the thermometer. And we're going to do this with one more block. So we've done the iron, we've done the aluminium, considerable difference in time, and we can try another block. I've got copper here, we can try that one. So I'll set the thermometer and block to see what that's going to be. And while we're doing that, I'm going to wrap this up in the insulation material. And we'll leave that to get to the right temperature. The copper block that we're looking at now, again, 1 kilogram. We're going to use 12 volts, and we're going to use hopefully 0.8. I will try and put a sort of gaffer tape on there to hold it. Right, so we set that up. Pause to read the thermometer. Thermometer will hopefully get down to 26, and as I say, we're ready to start at 26.5 at the moment. And move these blocks out of the way. On 26.5. I think I'm going to say that's going to be 26.5, slight temperature difference. So 26.5 Celsius to start with. We're going to run the experiment for the third and final time. The thing is barely warm. Put this in. Push it right in firmly. And then let's start the clock again. 3, 2, 1, go. Just adjusting the voltage to make sure it's about 12 volts. This one is still now going between 0.7 and 0.8. Let's see how we're doing. Coming up on 1 minute. And at 1 minute, 32 degrees centigrade. This seems faster than the iron. So we've reached 35. We're going to have to stop this in a few moments. 35.5. And 36 will stop now. So the time is 1 minute 44. We're going to leave the system running as we did before to see what temperature we're going to achieve. My prediction is we will probably get hotter than the 42.5 we managed with the iron. It's shooting up faster. Iron conducted the heat seemingly worse when we did the other experiment. It sort of took longer to sort of held the heat and went up a bit more. And the copper, we know, conducted heat the best in an earlier experiment. And we can see that it's still rising here. We're at 39. 39.5. I don't think it's going to go any higher than that. I've got it at 39.5. And it seems fairly steady at 39.5. Okay. Let's just take a quick bit for a moment. And I've got my blocks. I've got my copper, which is obviously still quite hot. The iron and the copper feel more or less the same temperature. The aluminium a bit cooler. It's been going a bit longer, so maybe a good experiment here also is to look at how these lose heat over time. I'd expect the aluminium to be different because they are different sizes, different diameters. They are, of course, the same mass. Let's take these figures and go and have a look at them and see what we can do. So if we have a look at the figures that we've got, we'll zoom out a little bit. You can see what we've got. Well, now what we need to try and do is to sort of put these down as proper numbers so we can do them in the equation. So what I need to do is to convert the time to seconds. So what we need to do is simply work out what these are. So let's do the first one, and easy enough to work out. This is going to be then the energy is going to be 6 4 is 24, so 267 seconds times 12 times, it was an average between those. Let's go for 0.75. So let's have 267 times 12 times 0.75 gives me 2403. So that's for aluminium. Let's do the same for the iron while we're here. So 2 minutes is going to give me 120. So we want the 120 plus the 52. surprisingly 172, and we'll times that by 12, and we're going to times that by 0.8. And the amount of energy in there was 1651. I'm not going to bother with the 0.2, considering how inaccurate the other figures were. And my copper is going to give me 1 minute 44 seconds. So that's going to be 104 times 12 times, I'm going to go for 0.75 again, and that's going to give me 936. So we can immediately see here that the energy put in was considerably different, but then our temperature range is different as well. So let's have a look at those. My temperature range for my first one was 39.5 minus my 26 starting, which gave me 13.5. So E equals MC delta T. I want to work out what C is, so I'm going to take my E, I'm going to divide it by my mass times the change in temperature. That's going to be 2403 divided by 1000 times the temperature change, which is 13.5. Compare that with the other one, which is going to be 1651. This is iron divided by its mass, which is again here 1 kilogram, just under 1 kilogram. So when I'm going to divide this, I'm going to actually divide by 1, not 1,000 grams. I'm going to convert it into kilograms. So 0.95, and times that by the temperature change, and the temperature change for this one is going to be 42.5 minus the original starting temperature, 26, which gave me 16.5. And my final one was 936 divided by my 1 kilogram times by the temperature rise, which is 39.5 minus 26.5, which is going to give me 13. So let's work out the specific heat capacities of each of these items. So we've got 2403 divided by 13.5 gives me 178. We've got the 1651 divided by 0.995 and divided by 16.5 is going to give me 100, near enough. And the last one is going to give me 936 divided by 13, which is going to give me 72. So, according to my experiment, and we've got all manner of errors in here, we've got aluminium at 178, iron at 100, and copper at 72. Now, if we look up the specific heat capacity of iron, and let's just do that. Yep, that's not going to work very well, is it? Right, okay. So let's try specific heat capacity of iron. Hopefully it'll work out what SHC is. Specific heat capacity of iron here is coming out at 129. We got 100. For copper, it comes out at 385. We got 72. And for aluminium, they got 897. And we got 178. So our figures here are way off. Does that matter? No, it's science. These are the figures that I got when I did this experiment. And I didn't do it very accurately. And I did it really quite quickly. And with all experiments, I need to repeat them. And I need to make sure my insulation's better. I need to make sure on these blocks that for my block, my immersion heater doesn't sit in all the way. So I've got about that much left over. That's radiating heat out. That's wasted energy. So this is not a very accurate experiment. But what it does do, it gives an indication of how you could work out specific heat capacity. So until next time, take care, stay safe. Bye-bye.